fundamentals. Okay, now fundamentals. Now remember when we spoke about setting up the various resources that we require, right? So one is the data center, right? What do we need? We need the data center. So what are data centers? So data centers are essentially places where you have these huge, number of IT resources in terms of hardware, right? So going back to that point, we would need a large data center, right? So these are large campuses which are generally close to water bodies because they generate a lot of heat. And since you guys are from computer science background, heat is not good for computing, right? So there is a lot of cost involved in maintenance of these data centers as well, right? And it also has a very high physical security. It's not just the security of the hardware, but security in terms of your physical security as well. Like for example, AWS, people don't know where exactly AWS data centers are. For Azure and Google, some of them we know, but AWS data centers, people can't pinpoint and say that that is an AWS data center, right? So they have that level of anonymity, right? So data centers, and then within the data centers, we have availability zones. So I'm sure that you must have heard of the term availability zone earlier during the presentation, right? So what is availability zone? So here, what I'm trying to do is I'm trying to help you understand what is the infrastructure model of something that is on a cloud. Okay. So the first thing is obviously data center, right? Now what happens is a data center, right, is then a few data centers are put together. Now these are the 3 data centers, right? Now each of this data center has its own connectivity, has its own network, and has its own power. And then in addition to that, it has backups for all of these as well. So if one goes down, the backup is already up, and making sure that that particular data center does not go down, right? And that's managed over a cluster of data center, right? So when you put a cluster of data centers together in a particular region, right, that becomes your zone or availability zone. Now, these data centers can be at the same location, or they can be away from each other as well. So this can be at one location, this can be at another location, and this can be at another location, right? And they are not going to be dependent on each other. They're going to have individual connectivity, network, and power, right? So there are certain criteria, like all the data centers would be approximately 150 kilometers from each other, right? And things like that. So what happens is, essentially, the idea behind this is that if one data center goes down, it does not cause havoc in the other data centers as well, right? So this is the process of elimination. So if there is one data center which is having an issue, that issue should not cascade onto the other data centers, which is why it has individual connectivity, network, and power, right? So if one data center goes down, the others are able to work just fine, right? Similarly, right, there is another zone. This is another data center, right? So all these are put together to call an availability zone. So this is our availability zone 1. This is our availability zone 2. And both these zones are connected as well. So if this zone goes down, you still have zone 1, which can take care of your information and data, right? So the first concept is, or the first fundamental is your availability zone. Then there is a region. Now, region is on a broader or on a larger geographical area, right? So to give you an example, Mumbai is a region, right? Mumbai is an availability zone, right? Which has multiple. So Mumbai as a location has multiple data centers, right? So they get earmarked as availability zones, and then Mumbai itself is considered a region, right? Similarly, North Virginia is a region, right, within which you have multiple availability zones, right? So this is what a region looks like. A region will have multiple availability zones, right? And this is where you are able to create the high availability function of cloud services. So what you could do is you could have your primary at zone 1, and then you could have your secondary or tertiary at zone 3. Now what happens is, if zone 1 goes down, you still have information available in zone 3, and ergo it does not affect your business, and you're still able to run your business smoothly, right? So this is the second fundamental concept that we need to be aware of, which is region, right? Next is hardware, right? Under hardware, we have servers, storage, and network, right? So let's say, what is a server? A server is essentially a compute resource, right? So it has cores and it has memory, right? Now, what does this do? The cores help you in processing the information, and the RAM provides the required memory for functioning of the processing, right? So there are different types of compute resources. There are compute resources which are, very high in memory. So they are memory intensive computing, right? So they will have a very, very strong CPU base as well. Along with that, they will have a very large memory allocation, so that anything that requires high memory calculations can be done, right? Similarly, you have something for a compute type which is for storage, something that requires a higher IOPS, input output transactions. So there is a type of compute that is available for that as well. Then there is another type of compute which is exclusively compute, wherein there's a very high number of computation required, but memory is not. Memory is not a function of it, right? So you have intensive compute resources as well, right? And then there are also generic resources which have an equal ratio of, or a certified ratio of CPU cores and memory. So these are called general compute resources, right? Then we have storage. In storage, we have three types of storage. One is your block storage, right, which is represented by this icon, right? One is your file storage, and one is your object storage. So essentially, what these mean is, these are the various types of storages that you use based on what kind of data that you're storing, right? So if in your computer you use block storage, EBS, right? So what is EBS? EBS is essentially where the data is broken down into smaller parts, and when you read or write, or when you update the data, only that piece of data gets replaced or updated. Let's say, for example, you have a piece of data that is split into 16 blocks, and you've made a small change, and this change affects only the 15th block of the whole set. So only the 15th block will be accessed, and it will be replaced / updated with the data, with the changes that you have made. So what happens with this is, the transfer this particular interaction is of a very high speed, and because it's immediately available, it becomes strongly consistent. So strongly consistent is a term wherein if you update something, right, and if you read it immediately, you should be able to read the latest update, right? And this is generally used for structured data, because structured data is what you can split into blocks. If it's unstructured data, you can't split it into blocks. And even if you split it into blocks, you will not be able to put everything together, because there is an additional algorithm required for you to then, metadata, there's an additional algorithm and additional metadata which you will need to mark each of the blocks, tell them, which blocks come first and which blocks come second, right? So that adds on to the weight of the solution itself, right? And then there is file system, which is your network file storage, right? For something that can be accessed over the internet or over a network from various devices, right? So based on that, you try and use whichever you require. Like, for example, if it's your compute service, you generally have a block storage available with your compute service to perform the functionality. File storage is going to be something that you want to use across or shared with different other computers, because on your compute service, the block storage is exclusive to your compute service. A file service, on the other hand, can be for multiple computers. And finally, you have the object storage. Now, object storage is unstructured, like I said, so you can drop everything in it, right? So your object could be a video file, a picture, or in an Excel file, and anything, right? And these have various different interfaces of communication. So depending upon what your use case is, you use these three types of storage services or storage options. Then we have network. So here, remember, we are at the hardware section of the of the cloud services, of the cloud fundamentals. So there is a firewall. Now, what a firewall does is you set up rules, and then it only allows traffic that you have recognized and allowed to come in, right? So there is a physical firewall, and then there is a software firewall as well. But here we're just talking about the hardware firewalls. Similarly, we're talking about hardware routers, hardware switches, and load balancing, right? Now, in this, firewall is available as a software solution, right? So you have software firewalls as well, and load balancing is also available as a service. So essentially a software, right? Now, all of this is required to redirect the network, right? And based on, so like, for example, if you have traffic coming from, let's say you have a service in Europe, and then there is traffic coming from France, right? You will need to redirect that traffic to your French pages. But if it's coming from Italy, then you will need to redirect that to a compute or a web interface server, which has the language of, which is in Italian, right? Similarly, if there's somebody if there's somebody trying to access that from Indonesia, you have to redirect them to the web page which is in Bahasa, right? So these are some of the things that are required. Like, if you remember, if I don't know if you have noticed this, if you go to if you go to Amazon and just type amazon.com, it takes you to the amazon.com web page, which is the United States web page. But then it does tell you that, hey, you're not, you're from India. Would you like to go to the Indian web page, right? How does it do that? It's because of all that information that's gathered and the routing availabilities. Okay, then security. Now, this is one of the most important concepts that is there in cloud, right? So let me tell you why. Now, remember when we were talking about what are the various, what are the various features available, right? And we were talking about how the data that you store, right? All of your data is not in your premises, right? You've put it on the internet and it's gone and sat with whichever region that you have decided it will sit on. And that's managed by the cloud service provider or the cloud vendor, right? For companies who like, you can't say that companies don't don't worry about security, but then for some companies it's okay, because they know, for them, the fact that they know that it is there, and then there are security services in and around available for those storage services and for those data centers, they are okay. But what about companies like, for example, government institutions, pharmaceutical companies or healthcare companies, research and development companies, economic companies, right? Who need to make sure, or make sure that the data that they have is absolutely secure, right? So in cloud, there is this concept of shared security, right? So what does that mean? So essentially what it means is anything that is in the cloud is your responsibility. Anything that's off the cloud, right, is the cloud service provider's responsibility. So I'm going to rephrase that again, right? So for any security related aspects in the cloud, like for example, your data, who all you give access to, how you manage your firewalls, how you configure your operating systems and your upgrades, how you configure your customer data, and how you give out accesses to the data to others, your network encryption, whether encryption is enabled at rest or in transit, this is your responsibility. The security of the cloud, right, which is starting from where the cloud service is hosted. So the data center, the hardware in terms of infrastructure, resources, right? The storage, the networking, the availability of the making sure that the availability zone is up and running all the time. If there is a breakdown, to get that fixed, right? Security of the cloud is for the cloud service provider, right? So this is a very high infrastructure model, right, or shared security model, wherein it tells you who all deals with what, right? So if you look at it, if you are using an on-prem system, if you're using IaaS, PaaS, or SaaS, let's not worry about these three, right? I know these are acronyms. So these stand for infrastructure as a service, platform as a service, software as a service, and function as a service. So these are the service models of cloud, right? But let's not worry about these right now, because I will explain these as well. Let's just talk about on-prem. So on-prem is something that is your data center. Your data center is called on-prem. Okay. So you see, the physical security, the host infrastructure, network control, application controls, identity and access management, endpoint protection, and data classification, right? All of that is your responsibility. Whereas in the cloud, depending upon what service model you go for, right? You see, till the hardware, right? It is both yours and the cloud service provider's responsibility. But once we get into the data systems, it is exclusively your responsibility, right? So this is something very important in cloud, and security is taken very, very seriously. So there are a lot of clouds who are certified and audited regularly, so that they are prevalent with the existing norms of compliances. So there is HIPAA compliances, which is for, healthcare products. And then there is SOC compliances, right? So these are things that you would need to learn and get used to about as well, when you're wanting to discuss anything about in the cloud, right? Especially in terms of security. All right, so that ends that section. Now what we're going to do is we're going to talk about few basic concepts related and that are going to be useful for you in your future cloud journey. Okay, so the very first one is the OSI model, right? Now, I am pretty sure as a computer science student, this is something that you will need to be very familiar with, right? Because what happens is the better you understand these 7 layers, you're going to understand the various cloud services that are available, right? Like, for example, if you understand this better, you will understand a service known as web application firewall, right? So there are 2 types of firewall. Remember, I was mentioning that there are firewalls which are hardware and which are software firewalls, right? Within that as well, there are 2 different types of firewalls, right? One can identify and help you with eliminating unnecessary accesses at layer 4, which is your transport layer, and deals with the various protocols, right? But it is unaware of layer 7, right? Which is another type of firewall, which is called your web application firewall, which is layer 7 aware. So it is aware of the protocols like HTTPS, SSH, and DNS, right? So there is a lot of information that comes, that you're able to see a lot into the type of traffic that is coming to your estate, right? And it helps you in setting up vigilant activities, right? So that you don't fall under any nefarious activities like hacking or phishing and things like that, right? So it is very important that you understand the OSI layer, because a lot of services are, at the end of the day, work on these, right? The next important concept is virtualization, right? So yes, there is a lot of data on this slide. There's a lot of wordings on the slide, but let me explain it to you in a very simple way, right? So imagine you have your desktop at home, right? So let's say your desktop is an octa-core, right? And it has 1 TB of space with about, let's say, 32 GBs of memory, right? Now, when you use your computer, you're only using a very small percentage of the resources that are available to you in a computer, right? Most of us, we end up either watching something on the computer, or if you are an ardent gaming fan, then you use it for gaming, right? Even when you're gaming, right, depending upon the type of game that you're playing, you would either be using one of the 2, right? You would be either using a lot of CPU or you would be using a lot of memory, right? Like I said, depending upon the game, this will obviously change, right? So now what happens is, even if you're using your computer at 60%, right, there is 40% of resources that is still going to a waste, right? So to get around that, IBM came up with this concept of virtualization, right? So what virtualization does is, it creates an abstract layer over the hardware, right? So that what you can do is, you can set up many more computers over your computer. So these many more computers are known as virtual machines. So these virtual machines will have their own operating system. They'll have their own hardware, which is a shared resource, but they will all act as one different, one complete desktop, right? So in this example, if this was your main server, you add a virtualization layer over it, and then what happens is you can have multiple computers here, right? All these computers are, segregated from each other. The data worked on this cannot be accessed by this, and all of that, right? So you see, this becomes much more efficient in terms of using the resource that you're having, right? Now, virtualization is of various types. The first one is desktop as a service. Now, desktop as a service is what we talked about in the cloud revenue model, wherein this is a reason why there's a lot of desktops available right now, virtual desktops, and how people are able to work from home, right? All they need is a laptop, so they can use their personal laptop to log into the company laptop, because generally not everybody who's working gets a laptop of their own from the company, right? So this has contributed a lot to the revenue of cloud services, right? Similarly, you have network virtualization as well. You have storage virtualization, data, application, CPU, etc. Right? But these are you don't need to know about these. You just need to know what is virtualization, and then based on that, whatever you take up, you can read about them further, right? The next important concept is hypervisor. Now, hypervisor is related to the virtualization of a compute service or of a desktop, right? So what does hypervisor do? It's a software layer that coordinates your virtual machine. So all these are your virtual machines, right? And then there will be a hypervisor over here, which will coordinate all these virtual machines to make sure that everybody is getting their share of resources and is happy and does the work efficiently, right? So it actually looks at what is the requirement, and then allocates the required resource. There are two types of hypervisor. One is called bare metal. Now, bare metal, as the name suggests, sits on the top of the hardware itself. Okay. Whereas the type 2 hypervisor, the hardware itself will have an operating system, and then on the operating system, you will install the hypervisor, and then the hypervisor will then have the various guest OS available as virtualized virtual machines. Okay, so that is a hypervisor. You don't need to break your head over it right now, but understand that these are the various terminologies and concepts that are required, right? This would not be needed in your day-to-day cloud activity, but it's always better to know what it is, right? And then we have something known as resource utilization, right? So the old conventional data centers, right, are what are called colos or co-locations. So what happens in a colo is, and these again, colo is a part of your on-prem data center infrastructure, wherein somebody will have a huge data center, and then you will go ahead and you will, they'll have these huge racks of servers. You will take your server and you will install your server in that particular rack, and the network and connections you will manage. The hardware and the security of the rack will be managed by the data center provider, right? And then you have a dedicated resource, wherein that whole server rack will be dedicated to you. Now, this is an option available both in on-prem. Obviously, on-prem is going to be dedicated to you by default, but in colo, this becomes another factor, right? Obviously, it's going to be more expensive. And similarly, in cloud as well, you have the same thing. And then you have resource pooling, like how we had decided earlier or discussed earlier, that, it is a big pool wherein you get a small chunk of the resource that you need, right? And then again, coming back to cybersecurity, there are remember, I spoke about the OSI layer, right? These are the various layers of cybersecurity, right? So perimeter is going to be something similar to your physical layer, right? And then you will have your network layer, which could be your T4 layer. Your endpoint is T5, application is T7, right, or layer 7. And then you have your data security, which is your data that it's your responsibility at the end of the day. Security is your responsibility, right? So you need to set up various checks, various measures, various activities, various, checkpoints across these layers. Now, finally, the last section is about the various cloud deployment models, okay, and architectures. So the cloud itself is divided into, based on the type of cloud service provider that you go to, can be public cloud or private cloud, right? So public cloud is like your cloud service provider, any cloud service provider. What they will do is so the concepts of resource pooling, right? Shared security, all of that falls into public cloud. So AWS is an example of a public cloud. Azure is an example of a public cloud because the whole public has access to it, right? Then there is private cloud. So private cloud is something where you either buy a dedicated resource in a cloud service provider's portfolio and use that exclusively for you. So nobody else, that whole system is being used for you. So here, if you see in this example, right, this server for a public cloud, this server could be used by company A, this could be used by B, C, D, E, and this could be used by E, F, G, H, right? So that's a public cloud. But here in a private cloud, all of these servers will be used by IMF and nobody else, right? So obviously, private cloud is going to be a little more expensive than your public cloud. Then we have hybrid cloud. So hybrid cloud is where, depending upon, so what you do is you have your on-prem data center as well. And then to move into the future, right, to keep up with times, you select the best available services from various service providers. Here, I have put the example of AWS and Azure, right? Then there is multi-cloud. So multi-cloud is where, depending upon which service you feel is best provided by a particular cloud vendor, you host your application on those, right? So let's say, and I'm just saying this as an example. Let's say you want to do analytics, you will do analytics in this. Let's say you want to do reporting you will take, Azure will take care of your reporting, everything that's done in terms of your data lake / reporting, right? And if you want to do anything in terms of your infrastructure development, your IoT, right? AWS will take care of it, right? So those are the various cloud models. Now, one additional cloud model which I have not mentioned here is called the Gov Cloud or the government cloud, which is exclusive cloud resources allocated to government organizations, right? I cannot create a resource, or I cannot have access to government cloud. You cannot have access to government cloud, but the Department of Transportation, right, can have access to. In India, it's Ministry of Transportation. They can have access to public cloud, right? So all their information will be on something known as a private cloud. Government cloud, right? And coming to the compute service models, right? Cloud computing service models. So here I've shown you three, which is IaaS, PaaS, and SaaS, right? So IaaS is infrastructure as a service. So what you do here is you essentially take the various resources available in the cloud, the infrastructure available in the cloud, and then you host your own application, right? So here you do everything A to Z. in terms of hosting your application. Now, platform as a service is for you to build and develop, right? Let's say, for example, you want to do some research. Now, for that research, there is a platform already available in the cloud computing arena. So you just use that platform to build. Like, for example, you can use Docker or Kubernetes, which are containers, to build your service, right? Then there is software as a service. Software as a service is something that you only consume. The best example of software as a service is Gmail. Gmail is an application, which is a software, right? What does it do? It helps you send out, receive emails, mark your notes, calendars, tasks, etc., etc. But can you make any changes to it? You cannot, right? Whereas something that is an IaaS, you can change and customize anything and everything, right? So customization is the greatest here, and there is no customization in SaaS, right? So this brings about the differences in the various computing service models. So this is when we say on-prem, we talk about your data centers. So in your data center, you can manage everything. You're the king, right? You're the king, you're the queen, you're the soldier, you're the minister, you're the hard worker, you're the slave. Everything is on you, right? But in infrastructure as a service, anything that's related to the infrastructure gets taken care of by the cloud service provider. And then anything that's in terms of the application and data gets taken care of by you. Then in platform as a service, only data and application gets taken care of by you. Whereas in software as a service, you cannot manage, or you do not manage anything, right? So I'm going to pause here for 30 seconds, right? Shruti, if you are still with us, right, what I'm going to do is I want to check with the participants if they want to throw the questions at me now, or do they want it to be done after we talk about training and certification, right? Now, there are various, like I said, there are so many cloud service providers now, right? So depending upon what you want to do, right? The first and the foremost would be to start off with the basics of everything, right? Now this course, this webinar is essentially the fundamental that covers everything, all the cloud, right? There are certain cloud service provider specific fundamentals as well that you will need to learn when you take up that particular cloud's courses, right? So AWS has a cloud practitioner essentials. Azure has the AZ900, and Google has the cloud engineer, right? So you can learn either by technology or / solution, or by your role. So what do you see yourself wanting to be, right? Based on that, you can you can go forward with your tracks and understand and learn and then get certified by those tracks, right? So for example, I'm going to show you an example of AWS. So when you start with AWS, the basic one is called cloud practitioner, right? And then once you finish your cloud practitioner, you could take up any of these associate level examinations, which is architect, operations, and developer, right? So architect is essentially for somebody who's going to design cloud solutions, right? Operations is going to be for someone who is going to be working on system operations, right? Whereas developer is somebody who will develop, solutions in the cloud for the cloud, right? And for the various services. And similarly, the professional ones are the ones for cloud architecting and DevOps engineer, right? And then there are specialty courses as well. These can be taken only if you have one of the associate level examinations. So it is available in advanced networking, security, Alexa skill builder, ML, DB, and data analysis, right? Similarly, you have Azure Fundamentals as well, which is the AZ900 course, and this is the track. Again, it is based on the role. So if you want to become an Azure administrator, you would have to do the 104 level, right? And if you want to become an Azure architect, right, you will do the 300 track, right? And then you have Google training. Now, these are the basic certifications that you have under Google training, like your foundation, architect, and specialization. So foundation is your cloud engineer. Again, these are available all on the website. You know, I will show it to you right now. Okay, so that is essentially about the training. Now, let's recap as to what we learned in today's webinar. So the first thing that we learned was the definition of cloud is going to be based on who you ask, right? And then what are the requirements of cloud computing in terms of the hardware, the infrastructure. Then we learned about the features of cloud computing and also compared those features to what NIST had confirmed to be the attributes of cloud computing. Then we understood some basic fundamental concept of cloud computing. The storage spectrum was one of them. And then we learned about what are the different cloud architecture models and the deployment models.